Hi, welcome to Scholarship granTEE. So a big problem in the US and throughout the world is that a lot of money granted because a lot of students do not apply and there is a lot of barrier in application. And the other problem is that in those applications, those who apply, there's a lot of bias, blind spots, and monopoly in the market. So there is a very centralized decision maker, which makes it a very biased. So we have a very simple solution. We have built a system that uses the AI consensus learning and a retrieval augmented generation to help students identify and apply to scholarships more fairly and efficiently. For the AI consensus learning, where multiple AI agents, they are working independently to analyze and gather data from the RAG agents, evaluate the applications, and vote on the decisions. And here's the RAG part, where we gather reliable information from trusted sources like university records, scholarship portals, and student forums. And these RAG agents sort of act as the information gatherers, feeding the data into our system. And these are trained on different separate databases. They have an overlap of around 30%.
Ready. I'm here to show the demo for application. We have three moving pieces. This is our UI, this is our TEE, and this is our smart contract, which is deployed on a base API testnet. Now let's go back to the demo and try to create a scholarship. You can view existing scholarships, and I already have one. Let's create a new one. Now the amount I'm using here is just in weight, so it's not a lot, but enough for testing. Let's create a description, a deadline date, and some requirements. So what happens is all the metadata we are entering right now will go back to the API server in a trusted execution environment, and the ID and balances go to the smart contract. So this is creating a smart transaction which posts the scholarship ID onto the smart contract and metadata onto the TE server. I can show you the execution right here. Yeah, we just post the scholarship over here, and let's just refresh this. And so this transaction created a scholarship on chain, and we can add funds to this by going to the manage page. So in the dashboard, we just created this one. We can add funds, let's say, yep. And this add funds is creating a smart contract transaction which stores it on chain. And we can also add fund managers. When I say fund managers, it means AI agents. So we'll have to add the address of the AI agent we want. So we have our TEE running here, and the agent address of that tied to that TEE. And we can add over here. What this says is that we are giving the permission for that AI agent system to manage the fund where they can send out scholarship and update the status of applications. Now let's try and apply for a scholarship through a different account. Let's test. When I go to scholarships, I see these scholarships, and let's say I want to apply to the SJSU one. I already have a sample essay here for that. I can put this down. And also we have users' private data such as social network IDs, URLs to their accounts. Each of them can be connected through OAuth procedures, but we don't have that implemented as of now. So we have a form where they can enter their credentials. And when I do save profile, we sign our message and send it as an authentication to the TE server. Our data will be stored over here. So you see a post user has been created where the signed message will be validated. So that's how we can take socials. And when we apply for a scholarship, the data including our personal data and our social network from the socials from the database will be used. So when I click on submit, I create an application ID on the smart contract and submit this data to the TE server, which invokes the agent. Let me just refresh here. So we have invoked the agent over here by calling apply. What happens over here is each AI agent will come up with their own decision. We have like around 3 AI agents, and we have 3 RAGs, and a combination of them, like each AI agent will try to make a decision using each RAG differently. So we have like 9 different types of agents, and we aggregate all of that decision and take the majority of the votes and decide whether a student has been accepted or rejected for a scholarship. What happens here is the aggregator just takes the majority, and after the decision is reached, we use a CDP agent kit to directly send out scholarship to the student. So the agent kit will trigger these functions: send scholarship and update application status. In case of reject, the application status will be updated to reject. Let's just wait until the processing has been done, because this will take a little bit of time. Yep, it looks like it's been done, processed. Yeah, it says payment sent. Let's go to our smart contract and see whether the payment has actually been sent. 21 seconds ago. Yeah, the ETH has been transferred from the contract address to our applicant address.
I'm already logged in with my wallet, and then let's try the assist feature where we can go in and see that there is a chat integration. We have 3 different types of integrations here. That is the concise, deep, and community, and that's based on the RAG models that we're running. We have 3 RAG models, and they are fine-tuned to do different types of activities. All right, let's do a deep search here. We can ask about a general question, which requires more of like a recursive approach to sort of answer, and see if it can answer us. So we got a response, and we can see that it's a very good breakdown, and we have the data on UC Berkeley, UC San Diego, UCLA. So the data is only trained on the UC schools, and you can see like all of the tips of research success it is pointing to, and you can see there's a confidence score that gives out the evaluation of what based on the sources, how much relevant, how much trustworthy these are, and we can see these are linking to specific website, which are this is the UCLA website for it. So we can also try the concise features, but this is going to give me a more fast and shorter response. Community is basically going to be the database is mainly on the news API portals, from the news portals, and also from the student forums and the Reddit. So the project goal was to basically align the focus on verifiability and trust in the AI-driven decisions. So instead of relying on a single system to determine scholarship outcomes, we use multiple independent AI agents that evaluate data from various trusted sources, and each agent processes the information securely and submits its assessment, ensure that no single point of control or bias can influence its results. That's the whole concept of consensual learning. And by combining this with the blockchain-based transparency, our system basically ensures that every decision is traceable and we can audit them, and also it's fair. So we basically reinforce the core values of a secure, verifiable AI that this hackathon is trying to promote. Looking forward, the things that we would like to improve is firstly, of course, the data set needs to be more structured, more accurate, and a bigger one. The other is that we could be fine-tuning our consensus models that adapt to better complex decision-making scenarios. Yeah, thank you.